Hi everybody, my name's Syed Haniff. I'm a solution architect at UBS. I want to talk to you a bit about how we built an integrated platform for distributing our data to our consumers within the bank. And in particular, one component of that, the knowledge base, which we used a graph database for, and which ended up to be a bit of a game changer in what we could do in the future. A bit about UBS. It's been around in one guise or another since 1854. It's a global bank. There's around about 60,000 employees, and it's split into 6 different divisions covering wealth management, investment bank, asset management, and a corporate centre. I work for a group called Group Data Services. It's unimaginatively titled, but you can imagine what it does is it's responsible for the provision of data to consumers within the bank. So consumers within the bank could be anything from trading systems who want to look up a financial instrument down to settlement systems paying money to our clients through risk and finance systems, etc. So the Group Data Services primarily looks after reference data. I'm not going to go and get into a debate about reference data because that could take up the rest of the day, let alone the few minutes we've got. But what I mean by reference data here is both externally sourced and internally sourced data within the bank. So it could be financial instruments, prices we get from the market, those are sort of external sources. It could be internal sources, trading agreements, the terms that we have with our clients, the client data themselves. These are all data that's sort of manufactured within UBS. Within the group, we look after 12 data domains. Within that, there's sort of sub-data sets, and we sort of send that data out over a number of channels. The important thing is, I guess, the number of integrations. There's lots of systems and consumers that depend on this data and need the data delivered quickly. So the talk that I'm going to tell you about now is about our distribution platform and basically how we changed it, why we changed it, and how graph databases ended up helping us a lot in that. So reference data distribution, we're supposed to provide timely, accurate, and complete data to both human users, mostly systems, and these users and systems get the data through a number of channels. Some web-based, most APIs, some direct database, and a lot of messaging systems. This is how our distribution platform looked previously. At the top, we've got our source, or master data systems, and we sort of have them organized pretty much in a normalized way. Account data lives in its own database, client data lives in its own database, etc. These are all relational databases. They publish out versions of the truth of the data they hold in a canonical format, usually an XML message, and they're sent down to our consumers who then have to sort of get each of these individual messages and join them up. So it was great for us. We could just have each of the individual systems publish out the data and leave everybody else to it. Not so great for if you're a consumer because you've got to go and join the data. Here's an example of one. It's a completely made-up example, so maybe there is an ABC Corp Trading Limited, but what we see on the left-hand side is a trading agreement. So it'll be the terms and conditions under which we trade with a party. On the right-hand side, there are 2 different parties. One would be a UBS party, bless you. The other would be the counterparty who we trade with. And they're sent out as 3 separate messages, and it's reliant on people to join those up later. Why did we want to change it? Well, that join, if we look at there, there's nothing special. It's pretty easy. But when you sort of multiply that by hundreds of systems having to do the same types of things and all across the other data sets doing the same sort of things, you get a lot of costs and a lot of complexity pushed down the data pyramid. It means also that our consumers have to keep an up-to-date copy of the data. They have to make sure that they've got the up-to-date copy, so there's the potential for staleness. And then also, we're sending all of the data out from the system in pub sub mostly. A lot of our consumers are getting data that they don't necessarily want. They're interested in specific products or specific clients or specific markets. So they end up having to eat everything and then throw away what they don't want. So this is the blueprint for our new platform. What's different, apart from it's in a different color and there's a few more boxes. The different bits really happen in the middle. So there's a pool of data where we hold it and join it. We listen to different sorts of data events come out, and then effectively we pre-join the data and then push it out via file or REST or messaging to our consumers. The bit I've highlighted is on the right-hand side, the knowledge base. Really, we wanted to write a platform that instead of writing separate connectors and ingesters and joiners for each of the data sets, we wanted to write something a bit more generic, where we could write a component once and then effectively use metadata to have these engines interrogate how the data's shaped, how it links with other data, and then do that joining. So that's really what the knowledge base does. We still send out the normalized data. There's still good reasons to have that. Not everybody wants to join data, but essentially the knowledge base is the thing that drives who wants what, and we'll see that a bit later. Here's the example we had before, but now it's nicely joined up, ready for our consumers to consume in that way. What are its benefits? Well, it's one platform. What I didn't mention to you is that each of those systems were publishing its own version of data. Now we can consolidate it. We talked about pre-joining. And this third point, subscription to attributes, we allow users to only specify what things they want to look at. We'll see that a bit later, and that's where the knowledge base and the graph database really comes into its own. So definitely more consumer-oriented, which is good, but there's still sort of things which we don't really know and would like to know. What data sets does the GDS offer, and what attributes do they have? How does an account relate to a client? That's pretty easy. Ratings to instruments, et cetera, but there's a wide range of data sets. Some of these relationships are non-obvious, especially when you look at sort of the different roles that clients can play in a trading relationship. So some of these questions, whilst the data experts will know it, not all of the consumers will. So third, the title's disappeared on that one, how do people get our data? And finally, who's using which attributes? If we've got an attribute which is going to be deprecated, if we've got attributes which we think the data quality may have issues in, we need to know who's affected. So what is the component that we did it? Well, I kind of spoiled it a bit earlier on by saying that's this knowledge base component that we've got. The knowledge base is just really a subcomponent of the system that really tracks the path of the data all the way from the master data systems, the source systems, through our distribution platform, and then all the way out to the consumers at the end. So, we've heard enough. We've heard a lot about graphs this morning, I guess, to say that that path of the source to the consumers to each of the transformations starts to look a bit like a graph. Here's the sort of the model that we have. So the source systems, these are the master systems like our client data system. It provides a service. Service might just be get client. That has an implementation. For example, it might be via a web service. It might be a message that we publish out representing a client. Those, the web service and the message queue are channels. The data set is the sort of the data description of the client itself. That client will have a number of attributes, a classification code, an identifier, a legal name. And then we have a number of consumers who want projections onto that data set. They want to say, well, I'm only interested in the ID and the name because I'm a trade system and I want to provide a list of values for the counterparty. This is sort of a simplified version of our model. There's a lot of other things that we hold in it, like how we manipulate the data into different shapes. But essentially, that's the model. So that's what we wanted to do in our new platform, and we wanted really a way of having the platform interrogate this model via APIs. Our first model, we sort of cheated. Well, we're a financial institution, so spreadsheets are very common. We used a spreadsheet. We made up a custom DSL, and there's an example of it. It shows 4 data sets. Bonds and equities are instruments, but they're separated into different data sets. That underscore from bond to bond rating as we join a bond to its rating from the agencies. Similarly, we join the equity to its rating, and then the comma meant that it was a join. So, yes, it was kind of clever, if a bit, well, not a bit, if very complicated to explain to new joiners. That's where we sort of did our modeling out, if you like, and used Excel as a modeling tool. We then said, well, that's great, but we wanted to have this, in a database that we can query with our components. So we looked at doing it relationally. We looked at some other things, and really, we said, does the model or does the relational version of the model answer our questions that we had before? It could do, but it wasn't very easy to make it do that. There's a lot of different paths through the data. There's lots of different entities. Sometimes there are transformations and multiple transformations. You end up with quite a lot of joins. You end up with different looking data flows, and it wasn't that easy. Here was our Eureka moment. It looks really obvious now, so that's why I put quotes around it. But when we looked at that again, it looked like a graph, so we sort of came to the stunning conclusion that maybe we should store it in a graph. It's always a bit embarrassing seeing it there, but it took a few weeks, possibly even a month actually, to get to that of our banging our heads. So what did we do? We decided to store it in a graph database. We used Neo4j. It was already in use in the bank. I think Emil mentioned at the start about the entitlement system and the groups in UBS. That was had been sort of pioneered in the bank by a team confusingly called Neo, which is the product, but they also use Neo4j. There was lots of resources online. It had the drivers that we wanted to, matching our language choices, primarily Java at the time. So we went and made a model in Neo4j. Here's the old browser showing some real data of one of our entities in there. So this is a financial instrument. It's an equity. Equities have lots of attributes about them. And then what we set about doing was really 2 things. One, building out the query layer to query the API. And the other thing was to really start saying, well, what other insights can we get from the data by just using the Neo4j browser and querying it? So back to the questions. The first one, what data sets and attributes do we provide? Well, here's, by the way, I should say the cipher here, it all works. This isn't the cipher in the APIs and stuff like that. The model's a little bit more complicated. But what data sets and attributes do we provide? Relatively straightforward one. I think, we can all imagine how we do it in the relational world as well. How are different data sets related? Well, again, I've done SQL for a few years. I can still picture it in SQL, but it would start to get a bit more complicated. So this really would be, I've got client data, I've got legal entity data, I've got instrument data. How do they potentially relate? They don't all relate together, but they've all got relationships with each other. Starting to get further down the model, how do users get our data? So, what channels are we publishing out of? How many published subscribed users do we have? How many people do we have who get file drops, et cetera, et cetera. And then finally, and this one really sort of, you could do in SQL, of course, in much the same way as I guess you could eat your lunch with boxing gloves on. It's going to get messy and you'll probably end up hungry. So which consumers are using which attributes? This one goes all the way up the graph to say, here's my master data systems. These are the attributes they have. Who's taking those attributes and how are they getting them? And this is really where the sort of the game-changing part came about it. Before we were publishing out a lot of data, we knew people were taking the data. We knew people were joining it and getting insights with it, sometimes because they'd find data quality issues or would have joined it wrong. But really, it was difficult to say exactly who was taking our data and how they were getting it. So that, by storing the data in a graph, because it essentially is a graph, it makes it a lot easier. What are the benefits of our knowledge base? Well, it's a single source of truth. Now we can sort of hold our metadata about the physical journey of this data in one place. Consequently, it means the governance of that data moving from place to place is a lot easier. We know what we're doing to it. We know who's taking it. Consumers are able to sort of understand, well, what data sets do we offer, and how do they relate to other ones, more importantly. And, we understand more. We find out who's taking our data, through which channels, who's using what, who's not using what. Sometimes there's data distribution that we didn't realize that we're doing that potentially actually can be consolidated into one. So there's benefits for both the consumer and for us in doing things more efficiently. What were the challenges, and some of them still are challenges. Not all data sets are there yet. Since this slide pack was done, virtually all of them are, but there's still a few gaps. In our graph, there's lots of data. I think in the simplified model, it was a simplified one. What it didn't cover is all of the different transformations and reshapings of the data that happen en route. So there is lots of data in there. It can be intangible at times, so trying to explain it or sell it to our stakeholders about why it's important was an initial challenge. I think that's becoming less of a challenge. I think with regulations around data lineage, people are starting to get the importance of the journey of the data. How did having it in a graph database help? Well, we saw the picture of the model where it's a natural flow of data from source attributes, transformations, transformation data sets, all the way down to the consumers and the views. That sort of traversal it would be tricky to do in relational databases. We add new attributes with each regulation or each new business that we bring on. We have new rules, new consumers. Again, a part of the advantage of holding this in a graph database in Neo4j is that we can add to that data model without having to go through a large modeling exercise. Finally, everything's an instance. It's often glossed over, but I suppose not all of these data flows are the same. Some are very simple. We get financial calendar information about holidays from various organizations. We pretty much push that through almost as is. Other ones are, require a lot more merging. Our account structures and data around our client roles is quite complex. So the fact that we can model these flows as instances makes it very, very flexible again. Neo4j itself, it did it. It was flexible. Cypher is an easy-ish query language. I did put easy-ish. I'm sure the Neo4j guys would disagree, but there's still a learning curve. It's natural, language, so it looks okay. But there's definitely a learning curve from a concept point of view. We had the drivers. So, we could just easily create an API, and the drivers were pretty rich in a natural API. We've had good performance, and we've had good support as well from both the Neo4j team and also actually our own internal UBS teams who know about it. Challenges, again, a lot of this has changed over time. So loading, at the time we did it, loading the data was manual and a pain. I won't dress it up. I think things have changed a bit more now with the ecosphere, and it's a lot easier. There weren't any out-of-the-box tools to manage the data easily, so again, we ended up writing a lot of scripts and having to test that. The skills were rare. They're still relatively rare, but they're easy to grow. I think there's been a lot of take-up. We've got now one team who's supporting this in our department. This is, and another one in the US who's developing a new application in Neo4j. So, and a third one around business structure data. So the skills are pretty easy to grow. So I'm laughing at this. This is an old slide, but still the next steps, a lot of them are still relevant. We highlighted the platform, delivering the platform piece first. We want to make better search, better visualization of this data. The ultimate goal is to really provide a self-service tool where people can sort of browse and request these data distributions for us. Our widening of coverage of data sets were pretty much there. Offered to other parts of the bank, I think there has been a fair bit of take-up around it. And again, the impact analysis tools, this is really part of, I suppose, my particular dream, where I want this self-service tool where people can look at that and say, well, if I were to remove this attribute or deprecate this attribute, or if I wanted this type of data joined with that, what would it be? How much would it cost to put together? How could I get it delivered, etc. So that's really the vision. We're part way towards it. I think this is, we implemented. We went live 2 years ago with it. It's running to this day, distributing data, no doubt now. So yeah, all in all, we're pretty happy with it. I think I've bang on for lunch. I'm happy to take any questions now, or I'll be hanging around for lunch and a little bit afterwards. So if anybody's got any questions, happy to take them.
Don't want to get very much between you and lunch, but if there is a question, I'm happy to take one. If not, thank you. Okay, thank you, Sid.
Cheers.